Hi class. Hello everyone. So today I want to talk about the digestive hormones or how these hormones regulate our digestive process. Alright, so let's talk about incretins. What is the incretin? It's something that lowers blood glucose. So its job is to stimulate insulin release and inhibit glucagon release. So it's basically responsible for lowering blood glucose. So here's the blood, here's the glucose. So, and it basically lowers blood glucose. That's what it says here. So the incretins like GLP or GAP that we will discuss shortly, they stimulate insulin release. So the key here is there's something, and that something are the incretins, and then something is digestive hormones or the hormones that regulate digestive process. They stimulate the insulin release. So the pancreas and the blood constantly passes through the pancreas is that control center that can regulate blood glucose. So if the insulin will be released, and insulin is a storage hormone, then insulin will lead to lowering of blood glucose. So when the blood passes through the pancreas and pancreas detects that there is increased blood glucose, in response, pancreas releases hormone called insulin, and insulin is a storage hormone. That's what it does. It stores. So it lowers blood glucose. It removes the glucose from the blood in a big sense. Also, incretins, they inhibit glucagon release. What is the glucagon? Glucagon is the opposing hormone to insulin. So the glucagon releases energy. The way glucagon releases energy, liver stores glycogen. Glycogen is the stored glucose. Glycogen is something that animals, humans, store energy, store glucose. We can also store glucose energy in the muscles. However, muscles are greedy and they will keep their glucose, their glycogen for themselves. So the opposing hormone glucagon, it's a releasing energy hormone. So the glucagon will make sure to release energy if the energy is low. So what the incretins do, they stimulate insulin release during the feeding process, and they inhibit glucagon release. So the glucagon will not release energy, and insulin will have a chance to store energy. So basically what happens, there's a tug of war between insulin and glucagon. When insulin is high, glucagon is lower, not completely low. When glucagon is high, then insulin is low. The only time you will see that insulin is, let's say, 100% and glucagon is 0%, or vice versa, let's say insulin is 0% and glucagon is 100%, when there's a damage to the pancreatic cells. So at the time when you do not really see insulin being released, it is when there is a type 1 diabetes and beta cells are damaged. So what I'm trying to say here is that there's a tug of war. When we eat products, when we eat food, energy appears in the blood and insulin would be released. So the glucagon also are constantly being released. It's just a small amount of glucagon that will be released. So the reason when insulin is released higher, right, and glucagon is lower, let's say, right, and here's the energy above the threshold, so we need to store glucose. We need to remove glucose from the blood. We need to bring glucose to the cell. We need to replenish glycogen storages. We need to replenish glycogen storage in the muscles. And if it's too much, we can store extra glucose as a fat in adipose tissue. But when the insulin is going to be very high after the meal, and few hours after the meal, the insulin can overstore. Maybe the pancreas produces too much of insulin, right? If the pancreas produces too much of insulin, then insulin can lower glucose beyond that normal level that the person can faint because you're removing energy from blood. We need energy being present in blood, so the glucose constantly being supplied to the tissues in the system. So that's why glucagon will be released. It's like insulin is trying to store, but glucagon will be like pushing back. It's like, no, do not overstore it, because we want to maintain blood glucose. We want to maintain blood glucose within that proper level. right? So not discussing numbers, within proper level. So the incretins, they do this very interesting job, and that's specifically GLP and GIP that we will discuss in another video. So they stimulate insulin release and they inhibit glucagon release. And obviously there are some enzymes like DPP4 that inactivates incretin. Alright, so I hope it was very explanatory. See you in the next video.